JWST data analysis tool notebooks. That's JDAT for short. And so let's talk about them. What are they? So what are the JDAT notebooks? They are Python Jupyter notebooks that illustrate workflows for post-pipeline analysis of JWST data. So this is the workflow that happens after you get the data processed through the pipeline, and you want to visualize the data, you want to analyze it, you want to analyze your spectra. These types of workflows are captured by these notebooks. And we expect though these notebooks are based on JWST data, we expect the workflows to actually apply to data from other observatories as well. And the notebooks attempt to utilize a number of software packages that we develop here at SDSCI, through the AstroPy community, through the Cubeviz organization, so a multitude of packages. And the notebooks themselves actually serve two purposes. It's a two-way relationship. On one end, they educate the astronomical community on how to use the tools we're developing. So you can think of them as interactive documentation, so you can play around with them, change the parameters, and so on. On the other end, they also help inform us, the dev team, what the needs of the community are. So whether it be while someone is using it or someone is contributing a notebook, if there is something that's missing, a tool that would be nice to have, that's our way of, this is one way we actually find out, we need to build this. So anyone can contribute a notebook, and I'll talk a little bit about that towards the end. But before we do that, let's talk about what actually constitutes the JDAT notebooks. So there is three components. Of course, there is the data. So this is JWST data, but since JWST is not in space yet, we're using synthetic or simulated data run through the pipeline. And the other component is actually the requirements file. And the requirements file is basically a pip requirements file. You can think of it as a recipe file of the modules and packages that are necessary to run the notebook itself. And lastly, you have the notebook. So this is the notebook that's going to showcase the workflow, the scientific workflow. And each one of these components is uploaded to, the cloud or GitHub. So the data is uploaded to SDSCI box, and anyone with a URL can actually download the data from anywhere. The requirements file and the Jupyter notebook are uploaded onto GitHub, where they are maintained and reviewed and so on, made available. So there are two ways of accessing the JDAT notebooks. So there is a static rendered notebook version, the one you see in the little laptop here. This is a bit outdated, the list probably changed. But basically this is the notebook after it's been run. We post it on this website so that you can get a quick look of what the notebook is for quick reference. But it's not interactive since there's no kernel behind it. Another way to interact with the notebooks is to actually download them or clone them from GitHub and build the environment on your local machine and actually run them, execute the cells. And so the link is here, but I always find it easy to show people how to get to the notebooks repository. If you do SDSCI GitHub, it will take you to the SDSCI GitHub. And then if you say JDAT, actually, you only have two options. If you click on JDAT notebooks, it will take you to this repository. This repository contains all of the notebooks, and over here at the top, there is a link to the static page. And if you click that page, it will bring up the a list of different notebooks, different science cases, and so on. So if you want to take a look, for example, near-count photometry, it's pre-rendered. You don't have to do much on your own. Okay. So with that being said, the other mode of accessing this is to actually clone them. So, you would do a git clone and then the URL to the repository. That will give you the pip requirements and the Jupyter notebook. And once you have this, you just run, pip install requirements.txt. And this will install all of the Python packages necessary. And you can just open up the Jupyter notebook and start executing the code or the cells. And you don't have to worry about the data because the data is automatically imported into the notebooks through a URL. So there is no need to download any of the data unless you want to, of course. With that being said, there is a review process that happens. So when a notebook lead, so a notebook lead is someone who's contributing a notebook. When a notebook lead contributes a notebook to GitHub, there is two reviews that happen. There is a technical review and a science review. And I should state that this repository is different. So if you're interested in contributing, please let us know. But on that repository, a notebook is submitted through a pull request, and the technical review basically deals with the PEP8 compliance of the notebook, the ability to actually build the environment, and so on. So it's very much technical oriented. And then on the other side, there is the science review, which makes sure that the science workflow makes sense, if there are any improvements that could be made, and if the plots make sense, and so on. So after it's gone through this review process, the notebooks are rendered and put on the static page I just showed you, and also made available to the public on the repository. Okay, so with that being said, we're always looking for scientists to contribute their science workflows or notebooks. And there's a couple of benefits of doing this. A chance to learn the latest technology we're building. And so you would be working with, or you would be in contact, at least in contact with some of the dev team, and also an opportunity to kind of direct the development of the tools we're making. So if you wished there was a tool and you think it would be useful for the community, this is your opportunity to let us know, because in your notebook you can state, at this point it would be nice if I had a function that did X, Y, and Z. And also an opportunity to actually learn GitHub workflow. So a lot of the science I've been involved with lately has been on GitHub, and I see it becoming more and more important as a collaborative platform. So it would be good exercise if you're not familiar with GitHub. But most importantly, I think the main benefit for the entire community would be providing learning and teaching resources. And I think that's the most important part of this.